Today we're going to go over some problems on completing the square. To solve any quadratic, you can always use completing the square. And we're also going to go through, when we're completing the square, and these exercises, we want to give our answer in simplest radical form. I'm first going to do a problem that, if you realize, you can actually factor this problem. You could actually say x minus 3, x minus 4. Because a negative 3 and negative 4 multiply to give you 12. A negative 3 minus 4 combine to give you negative 7. That means you would then set each of these equal to 0. You're using the zero products property. And you would get x equals 3 and x equals 4. So those are two answers. But I said we want to actually do this problem using completing the square, so that we get a chance to practice first where we're going to get integer answers. So the first thing we want to do in completing the square is get rid of the a term. There is no a term here. So next we want to move the c term to the other side of the equation. And I'm purposely going to leave some space here because I'm going to add some stuff in. So next you want to take half of the b term and square it. This is where a lot of kids pull out calculators when there's an odd b term. And they say, oh, negative 7 divided by 2 is 3.5. I want you to stick with fractions, because when we get to simplest radical form and we do a problem with a fraction, then obviously you can't have decimals. So half of negative 7 is actually negative 7 divided by 2, and we're going to square that. And we're going to do that to both sides of the equation. You don't have to get too hung up on your negative signs here, because in a minute this is going to become positive. Negative squared is always positive. And on this left-hand side of the equation, I'm not actually going to figure out what that is, because I'm only using that to actually then know what factors are going in my parentheses. Now, some kids ask me, where did the negative 7 go? It's there in the distribution. If I were to re-multiply this, I would get x times x is x squared. Negative 7 halves x for my outside terms. Negative 7 halves x for my inside terms. And positive 7 halves squared. Negative 7 halves minus 7 halves is negative 14 halves. And negative 14 halves is negative 7. Now, this is not part of completing the square. I've just done that step to illustrate that that negative 7 is still in there. Back to my problem. So to recap, I just factored this left side of the equation out. On the right side, I actually need to figure this out. Negative 7 squared is 49. And 2 squared is 4. So that's 49 fourths. I'm going to start combining some stuff here. So x minus 7 halves quantity squared. In order to add the 12 and the 49 fourths, I have to have like denominators. So that means 12 over 4 would not simplify, would be 48 fourths when converted to fourths. And I just realized, maybe you caught it, this should have been negative 12, because when I subtracted 12 from both sides. So now I have x minus 7 halves quantity squared equals negative 48 plus 49 is positive 1/4. Negative 48 plus 49 is positive 1/4. On the bottom, stays the same. So now I have a page extender tool. I now want to take the square root of both sides. This is a step where sometimes people forget what they're doing. To take the square root of a fraction, take the square root of the numerator and the square root of the denominator. And this is where you put in that positive and negative sign, because the square root of 1/4 is actually positive 1/2, because 1/2 times 1/2 is 1/4, as well as negative 1/2, because negative 1/2 times negative 1/2 is still positive 1/4. Now I need to bring the 7/2 over. Now, since there's no radicals here, I need to do a little more work here. So that means I have two problems here. I have x equals 7/2 plus 1/2, and I have x equals 7/2 minus 1/2. 7/2 plus 1/2 is 8/2, which is 4. 7/2 minus 1/2 is 6/2, which is 3. And if you remember at the beginning, we said that if we factored it and set those factors each equal to 0, we have solutions of 4 and 3. Remember, solutions in a quadratic just mean where the parabola is going to intersect the x-axis. So it's going to intersect the x-axis at 3, 0 and 4, 0. That's all we're doing when we are solving quadratics. The whole chapter, the whole lesson, this lesson is all about just finding where this parabola is going to intersect the x-axis. So now we're going to try another problem, and this time hello? Yes, please. So in this problem, unlike the last one that I just recorded, you have an a term. The first thing you need to do is get rid of the a term. So you need to divide everything by 3. X squared minus 2/3 x. Now, this is going to become negative 5/3. To save myself a step, I'm also going to move it to the other side. I don't really need that plus there, but I want you to understand, this would have been negative 5/3. I divided and moved it over at the same time. Now, next step, I have to take the b term and divide it by 2 and square it. We've already discussed that when I divide by 2 on a fraction, I could just multiply the denominator by 2. So 2/3, half of 2/3 is 2/6 squared. And I'm putting it in a different color so you can see what I'm doing. Okay, now the negative term is inside the fraction. If you mess up that negative term, it doesn't really matter, because eventually when I square a negative, it's going to turn positive. I don't figure out what this is here because I'm only using it to remind me that this is going to go in each set of parentheses, so that I have the same term, the same fraction in both sets of parentheses. Okay, over here I have 5/3 plus 2 times 2 is, and 6 times 2 is, 6 squared is, okay. Now over here I can turn this into x minus 2/6 quantity squared. On this side, in order to add these fractions, I need a what? Common denominator, so it's going to be 36. 36 To get from 3 to 36, I multiply by 12, correct? So multiplying by 12 on the top gives me 60. Now, I'm going to combine a few steps here. I'm going to take the square root because I can quickly see that this is 64/36. And when I take the square root, okay, so I'm going to over here do x minus 26 equals positive or negative. 60 plus 4 is 64. The square root is, and 36 on the bottom, square root of 36 is, so now I'm going to move this over. I have x equals 26, right, plus 86. And I also have, hold on, I'm going to write another one over here. So in this case, I'm not writing out the plus minus because since I don't have radicals, I can take this a step further. 2 plus 8 is over 6, and that simplifies to, okay? And 2 minus 8 is negative 6 over 6 is negative 1. What? It might have been. Okay? It might have been. Okay, so when it says write it in simplest radical form, that basically means if you hit a radical and you can't combine anything else, you stop. But here, I don't have a radical sign yet, right? Okay, simplest radical form means any number that's rational is going to be rational, okay? So I don't know why you're packing up. I still have 5 minutes, so there's no reason to be shuffling papers around, okay? Okay, so those are your solutions. Again, your solutions literally just mean if I were to graph this parabola, it would be going through -1, 0, and 5/3. Okay, also, the original equation was 3x squared. Remember the original equation for me for a second? Okay, so the original equation was 3x squared. What was it? And the solutions were 5/3 and -1, right? That means if I had realized it, I could have written, this actually would have factored. X plus 1, if I set that equal to 0, would give me -1, correct? And 3x minus 5, if I set that equal to 0, would have been 5/3, correct? And if you check this, x times 3x is, x times -5 is, x times 1 times 3x is, and 1 times -5 is. So actually this problem could have been solved by factoring. On the test, this is why you need to show your work. If you realize that it can be solved by factoring, that gives you a help for a way for you to check your answer, correct? Okay, so now I'm doing another problem, completing the square, and yes, I have an A term. So the first thing I need to do is get rid of that A term. So I have x squared plus 9 over 4x. Now I'm going to realize this is going to be 2 over 4, which is a half.
And since this is positive, when I move it to this side, it's going to become negative. So I'm going to do all of that in one step. Okay? Now, I need to take half of the b term and square it. So when I take half of a fraction, I can just multiply the denominator by 2, correct? So that's plus 9/8 squared. And I'm doing it in a different color so you can see. Hopefully it helps follow the steps. Okay? So I'm not right now on this side of the equation going to figure what 9/8 squared is. I'm just using that as a placeholder so that I understand that that's the fraction that goes in as the second term in each of my equations. Okay, so it's x plus 9/8. On this side of the equation, I'm actually going to figure out what that is. 9 squared is, and 8 squared is, did I lose somebody? Okay, the negative 1/2 came, this was when I divided by 4, this was 2/4, right? Which is the same as 1/2. I have to move it to this side. Okay, the 9/8 is what's half of the b term. 9/4, let me just do a little work over here. 9/4 divided by 2 is keep, change, flip is 9/8. Or you can remember that to divide a fraction in half, you're just multiplying the denominator by 2. Okay, but remember, I don't need to square it on the left-hand side because I'm breaking it right back out to factors. Okay? This becomes x plus 9/8 quantity squared. It's what's called a perfect square trinomial. The same thing is in both sets of parentheses. That's why it's called completing the square. We're making this left-hand side a perfect square trinomial. Spit out the gum. On this side of the equation, I need to, in order to add these, I need to convert them to common denominators, correct? So 1/2 has to become 32/64, and it's negative, correct? What is negative 32 plus 81? Okay, it's 49, right? The reason I'm doing this is because I'm going to save myself a step here, in that this is going to be a perfect square, right? So when I take the square root of this side, x plus 9/8 over positive or negative 7/8. That is not the answer. Now I need to move the 9/8 to the other side. No, we already did that. Now, if this were a radical here, then we would be getting to our final answer because it's in simplest radical form, right? Since there's no radicals, I have all rational numbers. That means I'm just going to have a whole number or a fraction. Yes. It should be. Thank you for catching that. Okay, thank you for catching that. So, no, so I basically can do negative 9/8 plus 7/8, and I can do x equals negative 9/8 minus 7/8. When I get to a rational number is simplest radical form. So simplest radical form means if you have an irrational number, you get to the step before you have a decimal. Okay? Because if you try to do like the square root of 45, you're going to get a decimal. That's why we end up converting that to 3 radical 5. Okay? If you have radical 39, you don't then turn that into an approximate decimal. Okay, I'm going to do one next if we have chance now. If not, I'll do it during 6th period where there's a radical. But, yeah. I converted -1/2 to 64. So let me go back down to here. Do you understand where I'm at here now? Well, now I have to do it. -9 plus 7 is what? -2, actually, right? And -2/8 converts to -1/4. That's one of the solutions. -9 minus 7 is equals -2. Now, had you realized, okay, what were my solutions? -1, what were my solutions? That means 4x plus 1. And what was it, a -2? If I had realized I could have factored this. Look, 4x times x is 4x squared. 4x times 2 is 8x. And 1 times x is 1x. That gave me 9x. And 1 times 2 is 2. So if you get a problem on the test that you realize you can factor, you still have to do the work for completing the square. Realizing that you can factor it is just going to help you know whether your final answer is correct or not. Okay, are there questions on this one? Yeah. Guys, somebody be asking questions and I'm still recording. Your answers are -1/4 and -2. You don't set these equal to zero. You're doing that when you factor and you have an answer like that. Okay. I'm recording. We'll talk about it later. So, in this problem, we're completing the square. The first thing we need to do is what? No. You divide everything by 3 to clear the A term. That, you're not at that point yet. Now, when I move the 10 to the other side, it's going to be +10. So I'm going to do 2 steps at once here, and I'm going to have 10 over 3. Correct? Okay. Now, this is where I have to divide the B term by 2. When I divide a fraction by 2, I'm recording. When I divide a fraction by 2, it's the same thing as multiplying the denominator by 2. So I'm going to add in here 4/6. Correct? Are you with me here? Okay. Now, 4/6 in this case actually simplifies to 2/3, correct? Emma, spit out the gum. Now I have video proof. You're in the video. Okay, so guys, this one is a little bit different. You understand why I have 2/3 there and not 4/6. Again, okay, over here, to make life a little bit easier, I'm going to go ahead and simplify 4/6 to 2/3 and then square it. So I have 10/3 plus 4/9. Correct? Here, I need to combine this to x plus 2/3 quantity squared. Over here, to add the fraction, I need to convert 10/3 into ninths. How many? So 10/3 is how many ninths? Okay, so I'm going to do a few steps at once here. I'm going to take the square root of both sides at the same time that I add the fractions. So on this left-hand side, it's x plus 2/3 squared equals 30 plus 34. 30 plus 4 is 34. The square root of 34 is radical 34. The reason we have a radical sign here is because 34 is not a perfect square. 9 ninths, the square root of 9 is 3. And we have to, this is where I have to put in my positive and my negative sign. Yes. Yes, thanks. I should have erased again. So you understand how I have that. Now I'm going to subtract 2/3 from both sides. I'm going to put in an extra step here that you don't really need to make sure you understand what's going on. So that means x is equal to 2 plus or minus the square root of 34 all over 3. So you don't need to write both for this one. So in the other ones that you, right now you're not getting the benefit of the 4 problems before this in the video. But in the problems before this, when we've taken the square root of this number, it's been a perfect square. So the reason that you stop here is because really there's nothing more you can do. You can't add 2 plus radical 34 or 2 minus radical 34 because they're not like terms. In Algebra 1, to get an approximate answer, you would have done 34 square root in the calculator and done 2 plus that and divided by 3 and 2 minus that and divided by 3. But we're going to Algebra 2. We want to make sure we understand simplest radical form. Yeah, if you wrote it as 2 separate answers, I'll accept it. You just don't have to. So now